Hi everyone, and a very warm welcome to today's webinar. Now let me address this model right off the bat because I understand it is a little bit unusual. When we create these webinars, we have a choice. So by my reasoning, why not choose an interesting model? Now I'm keen to stress here, although we're using this mechanical marvel, it doesn't really matter what you're designing. These simulation tools work in the same way and you still get the same great benefits out of them, even if you're not creating mechanical legs with talons on them. So let's get into this. We're going to set up a basic simulation study first to make sure that this knee plate is going to be strong enough for its application. Now we get the usual simulation tree here, and what I usually tend to do is work from the top down. First up, let's go ahead and define the material. As we know in SOLIDWORKS, we've got all our materials to hand here. If I open up the material database, you can see I've got my steels, my irons, aluminium alloys, and so on. And if that's not enough, we can create our own custom materials to use in our analysis as well. Now that's not going to be necessary for this analysis because the part is just a basic 1060 alloy, so we'll go ahead and apply as such. Now although the appearance of the part may change when we apply this, the more important thing is all the engineering properties are also changing, so we can be sure our analysis work is going to be accurate. Now of course, it wouldn't be an analysis without having some fixed geometry in here. That is telling the analysis how this model is constrained. As ever, we get the visual cues, so going ahead and making that selection, really easy to do. So we've got our material, we've got our fixture in place, next we just need a load. Now this being a full fat simulation package means we're going to have a few options there. In this case it is just going to be quite a straightforward force that we're applying. So again, using those visual cues, I'll go ahead and apply it to the face, but this time I want to choose the particular direction that that load is going to be applied in. So I'll go ahead and use the top plane as a reference, and then we'll just input the amount of newtons that we want to apply here. 7,500 let's go for on this run. And that's really it. That's all the information we need to add to run this model. Before we do though, we need to mesh it. Now meshing is the name given to the process that we do prior to running it, and it's where we break it down into individual elements. Now we can choose to make it very coarse and solve quickly, or very fine and solve a little bit slower but give us more accurate results. In this case, because the solvers in simulation are so fast, I'll generally go with a finer mesh and get better results out of it. You'll also notice once your mesh completes, SOLIDWORKS gives us a visual representation of it on the model itself, and we can start to see just exactly how small or how large those individual constituent elements are. And that's it. Let's go ahead and run this and get a look at our result set. So when we get our results, there's a couple of different options available to us. You can see this chart to the right hand side shows in scientific values. Now that's pretty common practice when it comes to simulation results, but I generally don't tend to work with scientific values, so I find it a little hard to interpret. So I can go into my settings here, I'm going to change it over to a floating value, and there we go. I find that much easier to work with. So just like many other areas of SOLIDWORKS, it's very easy to sort of customize and get it the way you like it. What this chart is telling me is that anywhere on the model that's highlighted in red or yellow is beyond the yield strength of the material that I'm using for this part. In other words, the part is most likely going to break or deform significantly at that particular point. Now it's always a good idea to go ahead and animate it and make sure it's deforming the way we would expect it. In our case it is, it's just that the material is failing, which isn't good. So next up I'd like to show you how SOLIDWORKS can not only tell us where this part's going to fail, but also make recommendations on what we can change to stop it failing. But before we get to that, I want to squash a common simulation misconception. And that is that simulation is just too expensive for the average engineering firm to be involved with. Well, I'll let you into a little secret here. When purchased from TMS, it's available from around about £40 per month, and that includes full support as well. Now here is the even better news. As an attendee of today's webinar, we're going to give you simulation absolutely free for 15 days. To claim your license, just get in touch with us using the details that will be at the end of this webinar. But for now, I'm keen to get back to the job at hand here, because we've got this knee plate, we know it's failing, it's got a material failure built into it. So how do we rectify that? How do we make a better part that's not going to fail? Well, here's one way. We can run an optimization study using the powerful design study suite built into SOLIDWORKS Simulation. The way that this is going to work is we're going to choose one area of the design, the whole size in this instance here, and we're going to set it up as a variable. Now, at its current size of 188 millimeters, it's leaving too small an amount of material, and that's why it's failing, I believe. So what we'll do is we'll set this up with a minimum size of 50, maximum size of what it currently is, 188. We certainly don't want to go any larger, that would leave less material. And we'll tell SOLIDWORKS, right, let's go through and optimize that value. Now the constraint that we want to optimize this towards is that the stress is going to be less than a certain value. In this case, I want it to be a little bit below the yield strength, so we'll go with 25 megapascals. And while we're at it, let's go ahead and set up a goal here that will aim to keep the part as lightweight as possible. So we'll choose mass for the sensor type and we'll tell it, okay, we want to minimize the overall mass. And that's it. We'll set this running, go get a cuppa and have a look at the results. Now you're going to need to make that a metaphorical cuppa because we've sped this along a little bit and it really does report back quite quickly. So let me try and talk you through what's happening here. So effectively, you can watch the size of that hole vary. That's as SOLIDWORKS goes through and it tries to determine what the optimal value for us will be. Remember, we're aiming to keep the stress low as well as the weight. And there we go. SOLIDWORKS goes ahead and determines what the perfect value would be. And what you'll also notice is it automatically updates our SOLIDWORKS model. We don't need to go back and make any changes or anything like that. So we're good to go ahead and save this. And if we wish to, we can even rerun that original study to get all the original result quantities, things like our stress or displacement or whatever else we need to include in our report. And on that note, imagine being able to provide comprehensive test results to your customers. Effectively saying to them, we guarantee the integrity of our parts, we stand by them, which not every competitor is willing to do. Now for the final 60 seconds of this webinar, I wanted to try and pack in as much as I possibly could. So let me show you how we could go one step further. We know this part will now survive one single cycle of loading, but how about over time? How many cycles is it going to be able to survive? Well, that's where this study type comes in, the fatigue study. What we're doing here is we're telling it to port over the original study, but run it 10,000 times. Now that's literally all we need to do because it ports over the material information, the fixture, the loads, everything we've added to that original study is immediately brought over. So there's no more setup for us and we just need to let this run. So when this completes, first thing you notice, well, it's probably my pet peeve of it reporting the value in scientific values rather than floating values. It's no problem to go in and change it. I should really set it up so that the template uses that each time. But hey ho, there we go, swapped over nice and quick. And we can begin to see, okay, so after 10,000 cycles, this is going to be 88 to 89% damaged. Again, think about this from your part's perspective. Have there been times in the past when it would have been useful to know exactly how many loads a part's likely to take before it suffers a critical failure? It's probably now becoming apparent that I could go on and on about the tools built into SOLIDWORKS Simulation. It's really hard to even scratch the surface in a 10-minute webinar. That's why it's such a good idea getting hands-on with these tools, and that's exactly what we're allowing you to do by providing you with free 15-day licenses for attending this webinar. To claim yours, just get in touch with us using the details on screen now. This has been Grant Davidson, and I look forward to speaking with you soon.